In this video, we're talking about how to find the scalar equation of a line given a vector equation and a coordinate point that the line passes through. So we have the vector equation v equals I plus 2j plus 3k. We can also convert this to direction numbers where we take the coefficients on I, j, and k. So the coefficient on I is 1, the coefficient on j is 2, and the coefficient on k is 3, and those are all positive numbers. So these are the direction numbers for this vector equation, and we know that the line is defined by this vector equation and this coordinate point, which happens to be the origin. Now when we're finding the scalar equation of a line, if we have these two pieces of information, then the solution is very easy, because to find the scalar equation we always use these formulas here: x equals x sub 0 plus at, y equals y sub 0 plus bt, and z equals z sub 0 plus ct. And what we need to know is that the values in this coordinate point here are x sub 0, y sub 0, and z sub 0. In other words, we're going to take this value here of x in the coordinate point and plug it in for x sub 0. We're going to take the value of y in the coordinate point here and plug it in for y sub 0. And then we're going to take the value for z in the coordinate point and plug it in for z sub 0, and that'll always be the case. So that's how we're transferring the coordinate point into these three equations. And then the values that we pull out of this vector equation, the coefficients on I, j, and k, 1, 2, and 3, they go in for a, b, and c. So in other words, if we're going to take this value here, the coefficient on I, it's going to go in for a always. The coefficient on j, in this case 2, is always going to go in for b. And then the coefficient on k is always going to go in for c. And the scalar equation of a line is going to be defined by three equations. Normally when we talk about the equation of a line in single variable calculus, it's just an equation for y in terms of x. But the scalar equation of a line is going to be given by three separate equations, x, y, and z. So we're going to go ahead and find these here. X is going to be equal to x sub 0 we pull from here, so we get 0, plus a we pull from here, so we get 1 times t, and the t always stays in there. Then we're going to get y is equal to y sub 0 we pull from here, and we get 0, plus b comes from here, so 2t, and then z is going to be equal to 0 plus 3t. So then we're just going to simplify, and we're going to get x is equal to, obviously the 0 drops away, and 1t is just t. We're going to get y is equal to 2t, and we're going to get z is equal to 3t. And then these three equations taken together as a group of equations define the scalar equation of the line.